x to the power of 5. We'll call it as index because it has a base of numerical value and also variable. So 2x whole to the power of 5. So this 5 is called as index. 5 is called as index and 2x is the base. 2x is the base. So index can be anything like it has the base of numerical value and also the variable. Both are present in this 2x whole to the power of 5. So for example, the base is x, the base is variable power of 5, then 5 is called as exponent. This 5 is called as exponent and x is the base. Coming to the power, if a constant is raised like 2 to the power of 5, we call it as a power, 5 we call as power and 2 as a base. So this is the difference between the exponent and power. Index we'll call it is the combination of variable and constant, that means 2x to the power of 5. The 5 is called index. The 5 will call as index. When variable is raised, we call it as exponent, and the constant is raised 2 to the power of 5. The 5 is called as power. So let's go to the laws of exponents. Already we have discussed the exponent, which is variable is raised. So some of the laws of exponents. So let's take first one. A to the power of n into a to the power of n. Here the variable is raised. We have taken m and n. This is the variable, base is the variable. And when the base is raised, the variable is raised to the power. We'll call as exponent. So m and n are exponents because a is a variable. So a power n into a power n. A to the power of m by a to the power of n. So when they are in multiplication, if they have the same base, different bases and the same power, and they are in multiplication, different bases we have, and the division in multiplication. A to the power of 0, where a not equals to 0, a to the power of minus n, a to the power of minus 1, a by b whole to the power of minus n. So here we have the sum of laws of exponents, and the bases are same and exponents are different. Here bases are same and exponents are different, and here these are bases are multiplication, here division. Here we can see the different bases, a by b whole to the power of n, and a into b whole to the power of n, a to the power of 0, a to the power of minus n, a to the power of minus 1, a by b whole to the power of minus n. So here, let us discuss about this all. So a a to the power of n into a to the power of n. When the bases are same, we'll add their exponents. Here we have the bases, same bases. We'll write as one base and we'll add the exponents when bases are equal. And during multiplication, we'll add their exponents a to the power of n plus n. So here we go to the second one. The bases are equal and they're under division. The exponents are different. And we write a to the power of n minus n. So there is this common relation between these two. Is they have the same basis, but here multiplication, here division. So when they are in multiplication, we added them. When they are in division, we subtracted them. There is a common relation between these two. Let's go to the next one. A by b equal to the power of n and a to b equal to the power of n. A by b whole power n. So this n belongs to the numerator and denominator for both. So we can write in this form a power m divided by b power n. A power n by b power n. So for all these, a and b are any real numbers. For all this loss of exponents, where a and b are real numbers. It belongs to R. So a by b whole power n, it belongs to for both. So m belongs to for both. So a power n by b power n. Similarly, it becomes for multiplication a power n into a power n into b power n. So m comes for both. And then the multiplication, there is a common relation between third and fourth. Here they are in division and multiplication. When they are in division, we have applied the exponent for both numerator and denominator, a power n by b power n, and when they are in multiplication, we have applied them a power n into b power n. So there is a similarity for third and fourth. And coming to the a power 0, a power 0, where a is not equal to 0, when base is non-zero real number, when base is a non-zero real number, because we said a b belongs to R. So where a is not equal to 0, base is not equal to 0, then any real number to the power of 0 except the base is not equal to 0, then answer will be 1. Any non-zero real number to the power of 0 is equals to 1. So a to the power of 1 is equals to a to the power of 0 is equals to 1. And coming to next one, there is a common relation between 6, 7 and 8, all the three. So let's take this in one group. A to the power of minus n, it has a negative exponent. So when we take this negative exponent as positive, it comes to the denominator 1 by a to the power of n. We have taken this exponent for the denominator, so it became a 1 by a to the power of n. Similarly, when we apply, if it is a constant number, any number, for example, this is 1. Actually, this is not the loss of exponent. Actually, this is not the loss of exponent. For example, we have taken the place of n as 1. So to understand the value of n is 1, what happens? So that's the reason we have taken 1. So as a law of exponent, we have taken it. So when we apply this rule 7 to the, when we apply the rule for 6 and 7, we apply the rule of 6 to the 7, and it becomes 1 by a to the power of 1. So because when we have taken the n to the denominator part, so it became 1. So let's write this 7th one there. So 7th one is 7th one is equals to a to the power of minus 1 is equals to 1 1 by a to the power of 1, because when we have taken this 1 as the denominator, it becomes to the positive value 1 by a to the power of 1. Similarly, let's apply this sixth rule of laws of exponent, sixth one for eighth one as it is. So we have taken this one exponent to the denominator, it became numerator. We have taken this one to the denominator, it became positive. Similarly, let's take this one to the denominator part, that is 1 divided by a by b whole to the power of n. So let's see once again, a to the power of minus n, we have taken to the denominator part, so 1 by a power n. Similarly, we have taken that a by b to the denominator, so n became positive value 1 by a by b whole power n. We got it. So here we can understand that there is one more rule can be applied for eighth one. It's not the final. So if we observe third one, a by b whole power n is a power n by b power n. So we can apply the rule for this a by b whole power n. So third one is a by b whole power n, a power n by b power n. So this is a by b whole power n. Let's apply this third rule for this. So it becomes 1 by a to the power of n by b power n. So this is the denominator part. So let's take this denominator to numerator, and becomes b power n divided by a power n. So finally what we understood is a by b whole to the power of minus n is equals to b power n by a power n. So that can be written as b by a whole power n, because using the same rule of 3, we can write it as let's write this a power n, a power minus 1 is 1 by a to the down, because we need some space here. So a by b whole to the power of minus n is equals to b by a whole b power n by a power n. So same rule can be applied, third one. So we can write as the same power, that is b by a equal to the power of n. So finally we got one of the law of identity for eighth one. This is the eighth one. Eighth one is this final one. So this is the second one. We have repeated that to understand clearly. So let's recall a power n into a power n, a power n plus n. A power n by a power n is a power n minus n. A by b whole power n is a power n divided by b power n, and a into b whole power n is equal to a power n into b power n. So there is a common relation between 1 and 2 and 3 and 4, and this is a unique one. A power 0 is 1, and where a is not equal to 0, we can take any number other than 0 as a base. So 6, 7 is a common similar relation we have. A power n minus 1 is equal to 1 by a power 1, a power n. So a power minus 1 is equal to 1 by a power 1. Similarly, we apply this rule, applying the same rule for 6 1 to this, so it became denominator positive. Then we transpose, we apply the 6th rule here, third rule to this, and we got finally b by b whole power minus n is equal to b by a whole power n. And these are the laws of exponents.